We're going to start our next chapter, which is going to be on series and sequences. Basically, we're practicing finding a pattern and adding up those patterns if they exist. So first, well, let's define what a sequence even is. It is basically just a list of numbers. And we're particularly interested in this list of numbers if they follow some sort of pattern. So I've put up here two that follow the patterns that we're interested in today. So can you figure out what goes in the question marks? What comes next? And hopefully you quickly found this one as 19 and then plus 3 more, 22 is what goes in those blanks there. And you probably found that by saying, okay, plus 3, and plus 3. So the pattern continues. We're adding 3 each time. Let's take a look at example 2 then. And did you figure out 48 and 96? And how is that? Well, if I looked at adding, I might think, well, plus 3. But this one is, how do I get from 6 to 12 by adding 6, right? And 12. So I would expect, do you see a pattern there? So plus, what would be next? Plus 24? But really, how many of these are there? 2? 2 of them, 2 of them, 2 of them. Wouldn't it be quicker to do times 2? So this is a multiplication. And we see the next 2 numbers. And we could keep on doing this. This pattern goes on for each of these forever, presumably. So example 1. This, when we repeatedly add something, that's called arithmetic. And here, example 2, if I, this adding of increasing amounts, that doesn't count. It's multiplying by 2 multiple times. That's geometric. So let's take a look at the properties of these two. So arithmetic, we are repeatedly adding or subtracting something, and that something is called the common difference. So right here I've set up 2, and what I'm wondering is, are they arithmetic? And if so, what is that common difference? So how do I get the common difference? Well, the common difference I could find by subtracting any 2, well, subsequent, they have to be in order, any 2 consecutive of the numbers. So these are called terms. So this 31 is actually called A1 because it's the first term, A being the name of our sequence. This would be A2, subscript 2, so this is the second term, A3, and A4. So if it is arithmetic, when I subtract these, so if I did A2 minus A1, that would be 49 minus 38, and I get 11. But I need to check the next 2. So that would be A3 minus A2. Notice I'm taking the larger, now not the larger term, the furthest term along. So the third term minus the second term. So 60 minus 49, that is also 11. And finally, I check the last one. That would be the fourth term minus the third term. And that would be 71 minus 60, which also gives me 11. So when I subtract all of these, the differences between them are 11 each time. So this one is arithmetic, and its common difference, we'll call it D, is 11. Let's take a look at this one. So if I'm trying to find my common difference, I do 35 minus 23, and I'll get 12. Okay, so plus 12 right here. And the next one, 47 minus 35. Well, that is 12, so plus 12. Good so far. And then 50 minus 47, notice I take the term furthest along, subtract the term behind it, and I get 13. So this one is not arithmetic, and we have no common difference. The next type was geometric. That's repeated multiplication. And the thing that we're multiplying by, it could even be a fraction, is called the common ratio. So let's take this first one. Now we find the common ratio like we find the common difference, except if this is A1, A2, A3, A4, instead of subtracting those numbers, I'm going to divide them to get the common difference. So I take the term furthest along, so A2, and I'll divide from A1, and that would be 8 divide 4, which is 2. Okay, so times 2. 4 times 2 is 8. And then the next one would be A3 divide A2. A3 divide A2. And I get 24 divide 8 is 3. So this obviously is not going to work out, but just to finish it off, the next one would be A4 divide A3. So that's 48 divide 24. And that gives me 2. So I don't have a common ratio. These ratios would all have to be the same. And they're not. Let's take a look at this one. So again, A1, A2, A3, A4. So if I want to find that common ratio, A2 divide A1. So that's going to be 36 divide 108. Well, that's a third, or 0.3 repeated. And then the next one would be A3 divide A2. So that's 12 divide 36. And that also gives me 1/3. And then finally, A4, the fourth term, divide A3. So that's 4 divide 12. That gives me a third, or 0.3 repeated. So I have a third each time. So yes, this is geometric, and my common ratio, I'll call it R, is 1/3. So that goes to that one, and this was my common difference for this one. So let's take a look at a few examples that they're all mixed up. So now we're asked, is this arithmetic, geometric, or neither? And I'm going to add to it, if it's arithmetic or geometric, what is that common difference or ratio? So if I look at the first one, it looks like times 3 right off the bat. But I see some negatives in there. So what's going on? So to get from -1 to 3 by multiplying by 3, wouldn't this have to be negative? So that would give me a positive 3. And then 3 times 3 is 9, not -9, so negative. Looks like all of these would be negative. So it is repeated multiplication. So our next term is -81. And since it was geometric, so it is geometric, our ratio is -3. We're multiplying repeatedly by -3. Well, let's look at the next one. Now, we might think, well, +1, +2, +2, plus what? There doesn't seem to be something going on there. But this is a pattern. It's just so it's neither. It's neither of the options. But what would come next? Do you recognize these numbers? You should. They are primes. So prime numbers are only divisible by 1 in themselves. So 2, 3, 5, 7 are only divisible by 1 in themselves. So what's next? 8, 9, 10, 11 is the next prime number, but these are not geometric or arithmetic. Let's look at this one. Now, I do see an adding thing, right? As I look at the denominators, +1 gives me 3, +1, +1, but I'm not actually adding 1, am I? So let's test this out. Well, now, we definitely have the 1/6 next, right? But we're wondering, is this arithmetic? And if it is arithmetic, remember, I should be able to subtract all of these and get the same thing. So I'm going to test that down here in the corner. So if I take 1/3 and I subtract a half, well, what do I get? Well, in order to actually subtract those, now you could use a calculator. I'm going to do it by hand. I need a common denominator. So if I subtract those, I get -1/6. Okay. And how about the next one? So if I subtract those, 1/4 minus 1/3, what do I get? Well, I need a common denominator. It's 12. So times 3 right here, and times 4 right here. And if I subtract those, I get negative 1/12. All right, so there's no need to go on. It looks like it might have been arithmetic, but it is not. So it's neither arithmetic or geometric, even though there was a clear pattern there. Let's take a look at this one. So it looks like I'm dividing by 2. But I need to be careful. So yes, it is divide by 2. So yes, the next thing is 4. And it's actually, though, it is definitely geometric. But remember, geometric is repeated multiplication. So what do I multiply 64 by to get 32? It's not 2. We can't think of division in this case. I need to think times a half, times a half. So my ratio, my common ratio is a half. Let's take a look at this next list of numbers. Looks like minus 4. So 4. So it is repeated subtraction, definitely repeated subtraction. So this is arithmetic with a common difference of, now I was subtracting 4, so negative 4. All right, good. Almost done, Or am I done? I think I'm done. Yep, definitely. Nope, one more. All right, more practice, same thing. Okay, so find the next term and identify common difference or ratio. So we've already been doing that. So, this one, what is going on there? Well, to get from 8 to negative 2, I'd have to subtract 10, and then subtract 10, and then subtract 10. So negative 32 is next. So arithmetic with a common difference of negative 10. All right, this one looks like plus 7, plus 7, plus 7. So plus 7, so 9. So it's arithmetic. Probably shouldn't just write an A. I'll do that. So our common difference is 7. So it's adding 7 each time. The next one, now it looks like divide 3, but remember, well, times a third. So 1/3. So that means that's geometric with a common ratio of 1/3. All right, so I'm having trouble right here. So minus 50, minus 40. So it's definitely not arithmetic, but is it geometric? And to know if it's geometric, I see if I have a ratio. So if this is A1, this is A2, this is A3, I'm looking for A4. I don't know what that is. Can't figure it out. But if it is geometric, I could do A2 divide A1, see what I get. And I could do A3 divide A2 and see what I get. And I'm going to go ahead and do that. I'm going to do 200 divided by 250. And when I put that on my calculator, I get 0.8. Now, 0.8 as a fraction is 4/5. All right, let's see about the next one. So the next one, A3 divide A2, so that would be 160. So I'm doing 160 divide 200, and I'm hoping I get 0.8 again. And I do. So 0.8. So in order to find this term out, I'm going to do 160 times 0.8. So 160 times 0.8, and that gives me 128. 128. So that was geometric because I was repeatedly multiplying by something with a common ratio of 0.8 or 4/5.